Hello and welcome. Today we're exploring SOX, the Safety and Security Engineering Workbench developed by EnCo software. SOX is designed as a powerful, adaptable environment to support key stages of the V-model development process. With SOX installed on your laptop, you have complete control over the interface, thanks to its Eclipse RCP foundation. This means you can customize your workspace, open specific views from any module, and arrange tabs exactly as you need them for a streamlined workflow. Each module in SOX can function independently, but they also work together seamlessly throughout the engineering process. From initial requirements gathering over detailed safety and security analysis up to test cases and reporting. This flexibility supports integrated end-to-end workflows that enhance efficiency across the board. Safety and security features. SOX places a strong emphasis on safety and security, with dedicated views and modules to manage each. On the left, you'll find a view for safety goals, while on the right, there's a view for security goals. Both are structured around the RECIF data model, making it easy to exchange data with leading tools in the industry. To support collaboration, SOX offers synchronization with tools like Polarion, Codebeamer, JAMA, and IBM Doors. Soon we'll also be introducing a Jira interface. In addition, SOX supports Git exports while also providing its own built-in versioning system, which allows you to create snapshots or baselines of the entire project. Projects can be easily exported as needed, and SOX's built-in MySQL database tracks all changes, enhancing traceability and ensuring that teams always have access to the latest information. With these features, SOX is designed to streamline both safety and security workflows, making compliance and data management easier. Workspace management. On the left, you'll find the workspace, a central hub where projects can be created and managed. Each new project is automatically stored in the repository, allowing colleagues to view and collaborate in real time. SOX's client-server architecture supports multi-user functionality, so team members can load the same project into their workspace and work with synchronized data. If a project needs to be removed from the workspace, it can simply be re-imported from the central repository, which stores all project files securely. This repository-based structure allows teams to access the latest project data, manage tasks efficiently, and maintain a consistent view across the entire team. Project structure and system catalogs. Each project in SOX begins with a default folder structure, organized to mirror the key stages of a development project, from requirements gathering and system design through to detailed safety and security analysis. This includes support for HARA, HARA, FMEA, FMEDA, FDA, and testing, right through to reporting. SOX offers cross-projects catalogs, where data like FMEA structures, bills of materials, and other reusable assets can be stored and shared across projects. Additionally, system catalogs contain standardized data sets, such as failure rate library based on standards like SN 29500 and IEC 62380, and various VDA, AJAC FMEA catalogs. These system catalogs are non-editable. To maintain integrity across projects, SOX includes a robust roles and permissions management system. This functionality is complemented by state machines for different modules, allowing you to model workflows such as requirements management to fit your team's process. Workspace details. In SOX, each workspace is connected to a repository, providing a structured environment for managing projects and their associated documents. The repository can be set up locally on your laptop or hosted on a central database within your organization, giving you the flexibility to work in line with your team's infrastructure. Each project within SOX follows a default folder structure that organizes documents by key stages of development, including folders for requirements, safety goals, security goals, system design, and analysis modules like HARA, HARA, FMEA, and FMEDA. This predefined structure ensures that all relevant documents are systematically organized, making it easier to navigate complex projects and locate specific information. Requirements. Within the Requirements module, SOX automatically generates standard documents for safety and security goals. These default documents cannot be deleted, ensuring that critical safety data is consistently available and managed throughout the project lifecycle. These entries for safety and security goals are automatically added to these designated documents. The Requirements module uses a tabular view to provide a detailed overview of requirement-specific information, including requirement status, assigned safety goals, and associated safety and security levels. This organized display makes it easy to manage large sets of requirements. Each entry's attributes are propagated automatically across related data points, ensuring that updates are consistently applied throughout the project. SOX also enables extensive configurability based on the Recif data model, allowing users to define custom types and attributes as needed for specific projects. This flexibility in data structuring ensures that the Requirements module can be tailored to meet diverse project requirements, offering a high degree of adaptability. Additionally, the Requirements module in SOX supports a range of import and export options, including formats like Recif, Excel, XML, and XMI. This flexibility facilitates smooth data exchange with external systems and enables teams to integrate requirements management seamlessly into their existing workflows. The import and export functionality allows users to share data across platforms, providing a unified workspace for requirements tracking and ensuring data consistency across all tools and team members. System design. The System Design module offers a comprehensive environment for designing and managing system architectures, entirely based on the UML and SysML data models to ensure consistency across all project elements. Every connection in SOX, whether it's between requirements, functional structures, or fault networks in the FMEA, uses UML-based connections. This standardized approach provides a unified structure, enhancing model-wide consistency and data integrity. At the core of system design in SOX is the UML Model Explorer, which enables users to create and visualize system elements and their relationships in a highly structured format. With full support for SysML 1.6, users can create various SysML diagrams, such as block definition diagrams and custom safety and security concept diagrams. These diagrams allow teams to represent dependencies, model functions, and malfunctions, and define safety and security goals. For example, users can create an asset definition diagram specifically for HARA, defining assets for threat modeling within security engineering. Using stereotypes, you can assign properties to these assets, which are then used throughout the HARA analysis for risk assessment. SOX also supports the drag-and-drop integration of requirements into these diagrams. Requirements either from the workspace or linked through external tools like PLM or requirements management systems can be directly incorporated into the diagrams, providing clear traceability across different project components. One of the key features of the System Design module is its multi-user capability, which allows team members to collaborate in real time on complex designs. SOX includes robust version control, role and permissions management, and a detailed change history for each object. This means that you can see exactly who made changes when they occurred and what was modified, ensuring transparency and accountability throughout the design process. For each object, a full change history is accessible, making it easy to track modifications and maintain control over project data, even in collaborative environments. In addition to facilitating collaboration, SOX is designed to support data reuse across multiple analyses. For instance, when a user creates an FMEA with fault networks, functional links, or safety goals, these elements can be directly integrated into further analysis, such as FMEDA or FTA, as needed. This capability allows teams to build data once and reuse it across various assessments, enhancing both productivity and consistency throughout the project. This reuse feature simplifies complex workflows, enabling users to leverage established data in new contexts without duplicating efforts. Standard diagrams such as block definition diagrams are fully integrated into SOX, allowing users to generate extensive system designs and model complex architectures. Each diagram created in SOX provides a comprehensive view of the system, and the data can be easily used across different analysis modules. Hazard analysis and risk assessment. The Hazard Analysis and Risk Assessment module provides a structured environment in SOX for conducting safety analysis compliant with ISO 26262 and other key safety standards such as IEC 61508, ISO 13849, and ISO 21434. This module is available exclusively in the web client. In the desktop client, HARA files are displayed and a double click opens them automatically in the web client, providing seamless access for users. The HARA module follows a systematic approach where system elements and their functions are analyzed in relation to potential malfunctions and hazardous situations. Key parameters such as severity, S-value, exposure, E-value, and controllability, C-value, are configured in advance and can be stored in catalogs. These standardized values make it possible to ensure consistency across different projects and analysis, allowing teams to apply predefined criteria when setting up each HARA. You can define effects and hazard reactions, both of which are critical or assessing potential risks. SOX then uses a built-in risk graph model to automatically calculate safety levels based on the predefined S, E, and C values. Once these safety levels are calculated, they are directly linked to safety goals within the system, ensuring that risk data is accurately propagated through the project. The calculated safety levels synchronize with the RCP desktop client, maintaining consistency across platforms without requiring manual data entry. A key feature of the HARA module is the tabular overview, which organizes system elements, functions, malfunctions, and associated safety levels in a structured format. This table provides a clear summary of each hazard, making it easy to track the current safety status and manage configuration efficiently. Dedicated views for safety and security goals provide synchronized access between the web and desktop clients, allowing team members to work seamlessly across platforms with full visibility of safety-critical data. Threat analysis and risk assessment. The Threat Analysis and Risk Assessment module offers extensive support for conducting cybersecurity risk assessments in compliance with ISO 21434. Just as the HARA, the TARA module is available exclusively in the web client. In the desktop client, TARA files are displayed and a double click opens them automatically in the web client. The TARA module organizes project-specific and cross-project catalogs, enabling users to define and categorize essential data such as global assets, cybersecurity claims, attack paths, and damage scenarios. For example, you can define an asset in the system and align it with specific damage scenarios and threat scenarios. Each threat scenario can then be broken down into attack paths, which are further detailed into individual attack steps, providing a comprehensive threat model that captures every potential attack vector. SOX supports several calculation models for assessing risk levels, including the rating approach, CVSS, attack feasibility, and attack vector models. These calculation options allow users to evaluate threats in a way that aligns with the specific requirements of the project. For instance, users can assign attack feasibility ratings and vectors to various threat paths, producing a quantitative assessment of each potential threat. As you work within the TARA module, any changes are tracked in a comprehensive history, detailing exactly when and by whom modifications were made. The change history is color-coded: yellow for updated, red for deleted, and green for newly added items, making it easy to review and audit changes. The TARA module also includes powerful dashboard functionalities, which provide an at-a-glance view of the current state of threat scenarios and risk assessments. The dashboard enables you to quickly identify high-risk areas and prioritize mitigation efforts. Attack tree analysis. In SOX, attack tree analysis is a crucial tool for systematically identifying and evaluating potential attack paths and weaknesses within the system. Currently, ATA is available in the desktop client, but EnCo plans to expand this functionality to the web client in the near future, offering teams additional flexibility. The ATA module enables users to create structured attack trees, breaking down each potential threat into attack vectors, subcomponents, and specific vulnerabilities. This hierarchical approach allows for a detailed analysis of possible attack paths and helps teams prioritize areas for mitigation based on risk level. In the future web-based version, the ATA module will retain all configurability and depth found in the desktop client, allowing for consistent and comprehensive threat modeling across both platforms. Failure mode and effects analysis. The Failure Mode and Effects Analysis module is fully compliant with VDA 6.3 and supports both product and process FMEAs, providing comprehensive tools for risk assessment and mitigation planning. The FMEA module includes both Action Priority (AP) and Risk Priority Number (RPZ) methodologies, allowing teams to tailor their risk evaluations to specific project needs. By double-clicking on an FMEA document, users can access a structured view organized by system elements, functions, and failure modes. One of the key strengths of SOX's FMEA module is its seamless integration with other modules. For example, failure modes identified in the HARA module can be directly dragged into the FMEA, creating a detailed fault network that connects malfunctions, causes, and effects. This network provides a clear visualization of failure propagation within the system. Corrective actions can be defined for each identified failure cause, with options to categorize these as construction or operational actions. The FMEA module in SOX automatically propagates safety levels throughout the system, meaning that each failure mode and associated corrective action is evaluated in alignment with the relevant safety requirements. SOX provides a variety of analytical tools within the FMEA module, including a risk matrix, malfunction analysis, Pareto analysis, and difference analysis, which allow teams to identify and prioritize failure modes effectively. Additionally, the FMEA module includes customizable form sheets for each system element. You can select the preferred format, such as AJAX or VDA forms, and switch between these formats as needed, allowing for documentation that adheres to industry standards on the fly. Bill of Materials. The Bill of Materials module enables detailed management of analysis of project-specific part lists, serving as a critical foundation for reliability and safety assessments within SOX. The BOM can be populated via Excel imports, making it easy to bring in comprehensive component lists as a foundation for reliability and safety analysis. Each component within the BOM can be configured with project-specific parameters, such as temperature profiles, mission profiles, and additional settings, enabling SOX to calculate effective fit rates for use in subsequent analysis. The BOM module is further enhanced by a wide range of failure mode catalogs. These catalogs provide standardized failure modes and component data that can be referenced across multiple projects, ensuring consistent application of failure data in various contexts. You can integrate these catalogs with your BOM, which helps streamline the data setup process by providing established failure data and reducing manual entry. Failure modes, effects, and diagnostic analysis. The Failure Modes, Effects and Diagnostic Analysis module builds upon the BOM to deliver comprehensive assessments of reliability and diagnostic coverage. FMEDA is widely used across industries, including at Bosch as a global standard for safety analysis. When creating an FMEDA from an existing BOM, users can choose between ISO 26262 and IEC 61508 standards, allowing for a tailored approach to meet specific project requirements. This module offers flexibility in extending analysis from left to right, enabling users to add detail progressively at each step. Upon opening an FMEDA, you'll see a structure similar to the BOM, with additional fields for safety goals and diagnostic metrics. The FMEDA module integrates closely with FMEA data, allowing users to leverage existing fault networks and failure data from the FMEA. You can start by opening a fault network within the FMEA and dragging a specific failure mode or hardware effect directly into the FMEDA. This drag and drop process creates a seamless link between the analysis, with each element from the FMEA mapping into the FMEDA structure. Once a failure mode from the FMEA is added to the FMEDA, you can link it to safety goals and add diagnostic metrics as needed. If further hardware effects are involved, you can continue by selecting them from the FMEA, dragging them into the FMEDA, and connecting them to relevant diagnostic elements. This step-by-step integration provides comprehensive traceability, allowing users to visualize the complete path from the root cause of a failure through to the hardware effect and ultimately to the system-level impact. The FMEDA module also supports detailed safety goal analysis. Multiple safety goals can be defined, each associated with specific relevance criteria and diagnostic metrics. Each diagnostic metric calculation is based on the individual safety goal, ensuring a precise goal-specific assessment. Additionally, the FMEDA module supports semiconductor analysis in accordance with Part 11 of ISO 26262, which includes tailored evaluation criteria for semiconductor components. Fault tree analysis. SOX furthermore includes a fault tree analysis module, which provides the tools to create detailed fault trees and conduct comprehensive safety analysis based on specific safety goals. The FTA module supports various gate types, with the default being an OR gate. You can manually adjust gate types to fit different logic structures, allowing you to model fault trees that accurately represent the logical dependencies in the system. The FTA module allows you to build custom failure models within SOX. These failure models can be integrated with elements from the FMEA or FMEDA, enabling users to drag and drop specific failure functions, causes, or effects into the fault tree. Additionally, you can incorporate entire modules or individual components directly from the BOM into the FTA. This means you can bring in all relevant parts from a BOM, which is especially useful for complex systems requiring a holistic fault assessment. Within the FTA, you can also integrate probability of mode of failure (PMAF) values from FMEDA, applying these probabilities directly to specific paths in the fault tree for more precise risk calculations. Test module. The test module is designed to ensure comprehensive coverage of all project requirements by managing test cases systematically and linking each requirement to at least one test case for full traceability. Each requirement must be associated with at least one test case, guaranteeing full traceability and verification throughout the project. The test module is built on the RECIF data model, allowing for organized structuring of test cases, test steps, and test modules within a clear hierarchy. Each test run acts as a baseline, generating a fixed outcome to serve as a reference point for comparison across different testing sessions. Baselines are essential for establishing a historical record of test results, making it easy to track changes and compare outcomes over time. SOX also supports an Excel round-trip process, which is especially beneficial for projects requiring data from external testing environments. You can export test cases to Excel, document or execute tests externally, and re-import the results back into SOX. This feature is particularly useful when data is collected directly from sources like a vehicle, enabling real-world data to be seamlessly integrated into the SOX environment. Export capabilities. The export capabilities in SOX allow for flexible sharing and documentation of all project data, ensuring that any document or analysis can be easily integrated with external tools. This flexibility ensures that all project data, whether it's an FMEA form sheet, an FMEDA report, HARA and HARA analysis, or other documents, can be shared, documented, and integrated with external tools as needed. For example, if you need to generate a detailed FMEA form sheet, you can open the document in SOX and export it directly to Excel, retaining all structure and data for further use. Report Designer. The Report Designer in SOX provides a robust web-based tool for creating custom reports and templates tailored to your project's requirements. To begin, you can access the Report Designer by double-clicking, which opens the web interface with a familiar structure used throughout SOX. In the Report Designer, navigate to the Template catalog to set up new report templates. Here, you can define placeholders, which serve as configurable fields that automatically pull relevant data from the project. For example, you might create placeholders for requirements, specifying which types, safety levels, or security levels should be included. This setup step ensures consistency across all reports, as each template can be reused across projects, allowing for uniform documentation, especially for critical reports like safety and security cases. These placeholders are highly customizable and can represent different object types within SOX. You can filter them by specific attributes, such as selecting only requirements that meet certain safety or security criteria. This level of configurability allows you to create detailed, standardized templates that reflect specific project and organizational needs, ensuring consistency in reporting formats across multiple projects. The Report Designer also supports adding visual elements, such as images and diagrams. SysML diagrams created within SOX, including block definition diagrams and custom safety and security concepts diagrams, can be directly embedded into reports. Simply drag and drop a diagram into the report, and it will be inserted as a dynamic image. These diagrams are automatically updated within the report to reflect any changes in the underlying model, ensuring that visual data stays current without manual adjustments. Underneath the diagram, there is a table that provides an overview of its components, including associated safety levels and other relevant attributes. The Report Designer supports generating reports in HTML and PDF formats. After creating an HTML document, it can be converted to PDF for formal documentation, ensuring that reports are accessible in both digital and print formats. This flexible output allows teams to generate clear, standardized reports that include text, diagrams, and dynamically updated project data. Conclusion. SOX by EnCo Software provides a comprehensive suite of tools designed to support every stage of the engineering process, with a particular focus on safety and security. From requirements gathering and system design to detailed analysis, testing, and reporting, SOX offers an integrated environment where each module can be used individually or in conjunction with others. This modularity allows teams to create seamless workflows across the entire V-model development process. With powerful integrations to tools like Polarion, Codebeamer, JMA, and IBM Doors, as well as export and synchronization options with various formats, SOX is built to adapt to diverse project requirements. We appreciate your interest in SOX and invite you to reach out to EnCo Software or one of our partners for more information. We look forward to helping you integrate SOX into your workflow to enhance your safety and security engineering efforts. Thank you and best wishes from the EnCo Software team.